Hello, I study in the Universidad Politécnica de Solotepec. My topic is electric circuit. For the subject Maths 2, I am going to explain the electrical circuit of the first applied differential equation. They are formed by voltage source, for example, batteries or generators. Uh, a resistant, an inductor, or capacitor. There are two circuits called CR and RL. Also, there are two principles for this. Kirchhoff current law, the electrical sum of the currents flowing at any junctions point must be cancelled. The second law, Kirchhoff's voltage law, the sum of the algebraicy of the instantaneous change in potential voltage drops around any closed circuit must be null. Let's go to the past the others formulas and the circuits.
Let's go continue with this. We have two circuits. The first circuit it is inductance and the second it is capacitance. In capacitance the energy is interrupted, so for that it is capacitance and it is called CL. Formulas. We have three formulas: to resistance, inductance, capacitance, and we have resistance. We measure in ohms, inductance in henries, capacitance in farad, charge in columbius, and current and amperes. Okay. Let's go with an example. In this example, set two 9-volt batteries are connected a series in which the inductance in 1 Henry and the resistance is 8 ohms. Determine the current IT if the initial current is 0. Okay, so from this problem we need to recognize L, it is equal 1/4. Resistance, it is equal to 8 ohms. As we have two 9 batteries, it is 18 volts. Okay, so this gives the differential equation. 1/4 times di dt plus ai must be equal 18. Now this is a linear first order differential equation. So let's go with ahead and put this in standard form. So we'll multiply everything by 4. Okay, this will give us okay di dt plus 32 I equal 72. 80 times 4 is 32. So we have 32I must be equal 4 times 80 is going to 72. Okay, now because this is a linear first order differential equation, we are doing to here to solve this using an integral factor where u of t is going to be equal to erase to the power of the integral 32 dt. Okay, again this 32 is the function being multiplied by I, sorry, or this case just the constant 32. So our integration is going to be erased to the power of 32t. Okay, now we'll multiply both sides of this differential equation here by e raised to the power of 32t. Okay, so we'll have erase 32t plus dt dt plus e 32 times 32i must be equal a to the 32t times 72. Okay, remember when solving a differential equation using this, the left side of this equation or the size here is always going to equal the derivative of the product of the integration factor. Okay, and our function I or I of t, so if the left side of this equation is equal to this derivative here, then this derivative must also be equal to the right side, or 72 times right to a power of 32t. Okay, now we can solve this for I by integration both sides of equation with respect to t. Okay, so now we can integrate the left side with respect to t and the right side with respect to t. Okay, on the left side the integration and derivative, and each other leaving us with erase the power of 32 t times I. Okay, on the right side we do have to perform a new substitution here where u is going to be equal to 32. T. So the differential u is going to be equal to 32 dt. So in performing this substitution, notice how we'll have an extra factor of 1 over 32. So we pass on the other side of paper. So E32t I. So integral here is going to be divided. It's going to be 72 divided by 32 times raised to the power 32t, sorry, plus our constant of integration. And now we can solve for this I. Okay, we pass another step. Okay, well, divided both sides by e to the power of 32t. Okay, so we have I of t is equal to this simplifies to 1. Okay, so we have 72 over 32, which will simplify the next step, plus c times e raised to the power of negative 32t. Okay, in this simplifies to 94, so we have I of t equals 94 plus e times e raised to the power of negative 32. Okay, now we'll find the value of our constant. We remember the initial current was equal to 0, which means which means I of 0 is equal to 0. Okay, so we'd have a 94 plus erase to the power of e to the 0, which is just 1. This must be equal to 0, so we have c equals negative 94. So our function I of t. Okay, that that tells us the current is equal to 94 2 4 minus 9 4 times e raised to the power of negative 32t. So this is the function that we are looking for, that will tell us the current at any time t.